Now that we've introduced exponential functions, we're going to need to have an inverse for the exponential function, and the inverse to the exponential function is called the logarithm. So we're going to try to come up with a definition for the logarithm right here. Now our objective is to invert the function y equals a to the x, the inverse function. We've seen several ways to find inverse functions, but one of the easy ways was to just switch x and y. So if I switch x and y in that equation, I get x equals a to the y, and y is the inverse that we're looking for. And then once we switch x and y, we solve for y. Well, I don't have any idea how to solve that for y. However, I can sure see what y is because I'm looking at it. So I'm just going to write down what y is, what y does. See, y is the exponent you put on a to get x. So I'll just say y, the log a of x, is the exponent of a that gives x. There's a nice definition for y. I put it in a more formal definition down here. I say y equal the log a of x. Read, y is the logarithm to the base a of x. That's how people normally say that symbol. Y is the logarithm to the base a of x. But what does that mean? How do you tell what y is? It means y is the exponent of a that gives you x. Now if that's the meaning, let's take this symbol, log a of x, and break it down. It's y is, that's the y equals part. The rest of this describes the symbol log a of x, the exponent of a that gives you x. So log then means the exponent. If you see the word log, it means the exponent. If behind the log is a sub a, that means of a. And if after the a there's an x, that means that gives you x. So if I see this symbol then, log 5 of 25, that means the exponent of 5 that gives 25. Well, 5 squared gives 25. So the exponent of 5 that gives 25 is 2. So if you saw this expression log 5 of 25, you don't read it log 5 of 25. You read it the exponent of 5 that gives you 25, and then you immediately know that it's 2. Okay? Now let's take a look at what the graph of this new logarithm function is and see if we can tell from its graph whether it is truly the inverse of the exponential function. So this next part says the graph of y equals the log 2 of x. Now when we graph the exponential function, we just grabbed arbitrary values of x. We can't do that here because the y we get has to be the exponent of 2 that gives us x. So the x's that we pick have to be things that are a result of some number being the exponent of 2. So for example, 8 is such a result because 8 is 2 to the 3. 4 is such a result because 4 is 2 to the 2. So for my values of x, I'm going to be very careful. I'm going to pick things like 8, 4, 2, 1, and then this is a little more subtle. We'll talk about that when we get there. 1/2, 1/4, 1/8, and then let's figure out the y that goes with them. So y is the exponent of 2 that gives us 8. Well, 2 to the 3 gives us 8, so y would be 3. If x is 4, y is the exponent of 2 that gives you 4. Well, 2 squared gives you 4, so that's a 2. If x is 2, y is the exponent of 2 that gives you 2, so that's 1. If x is 1, y is the exponent of 2 that gives you 1. Well, 2 to the 0 gives you 1, so y would be 0. Now what about a half? How do you get a half with an exponent of 2? Well, recall when we were doing the exponential, we found that 2 to the negative 1 was a half. So the exponent of 2 that gives us a half is -1, -2, -3. Okay? Now let's plot it. When x is 8, y is 3. So come out here to 8 and go up to y is 3. When x is 4, y is 2. When x is 2, y is 1. When x is 1, y is 0. When x is a half, that would be right here, y is -1, so that's down here. When x is a fourth, which is halfway to 0, y is -2. When x is an eighth, which is another halfway to 0, y is -3, so we're getting this curve. Now, for just a minute, let's recall the exponential curve. Y equals 2 to the x. If x was 0, 2 to the 0 was 1. If x was 1, 2 to the 1 was 2. If x was 2, 2 to the 2 was 4. If x was -1, 2 to the -1 was a half. 2 to the -2 was a fourth, etc. And so for the exponential function, we got that curve. And we said, well, the x-axis is an asymptote for y equals 2 to the x. Well, look at the asymptote for y equals log 2 of x, the inverse of 2 to the x. 2 to the x had the asymptote the x-axis. This has the asymptote the y-axis. Now, when we were talking about inverses, we found that from a graph, a way to find the inverse was to reflect a function around the line y equal x. So if I come in here and draw the line y equal x, notice what we have. This graph is a perfect mirror image of the other graph in y equal x, so that is indeed inverse functions that you're looking at. Now, think about the domain. Remember, the domain of the exponential was -infinity to infinity. You can see that from the graph. If you came up here to the exponential and dropped that down on the x-axis, you'd get -infinity to infinity. But look at the log function. It never reaches 0 and never goes negative. So the domain of the log function would be 0 to infinity. Consider the range. The exponential function never went below 0 and never touched the x-axis. So the range of the exponential function was 0 to infinity. And look at the range for the log. The log continues to go up forever and continues to go out forever and continues to go down forever. So when we collapse that back to the y-axis, we get for the log, the range is -infinity to infinity. Now, before we leave, I want to give you two special symbols. There are two logs that are special because they're the only ones that are on your calculator, and there's other reasons why they're special as well. The first one is the log base 10 of x. This is called the common log. I wish I'd written that first, but I'll just write it down here. The common log of x is the log base 10 of x, and just as a shortcut, because we use it so often, we just write for this one the log of x, and on your calculator the key will just say log, and that's referring to the log 10. And the other special symbol corresponds to that base e that we talked about on exponentials, that models nature. And so that's very important, and it's the other base that's on your calculator, and we call this the natural log. And it's the symbol we use for it is ln of x, and we don't put an e. It's not that necessarily that you're wrong to put an e, but you would be redundant. When it says ln, it means there's an e here, and the symbol on your calculator would be ln. And we'll continue on with this in the next podcast.